In this video, we're going to take a look at our last operation for polynomials, which is how to divide them. There's actually a couple of ways that we can do this. One way is long division, like you learned in elementary school. And there's another made up version that we call synthetic that we're actually going to focus on today. I'm going to show you both. The long division takes a little bit of work, so I have a couple examples here to show you, and I'm going to show you what this new type is that we're actually going to use in our assignment. So let's take a look at using long division to find a quotient. That's the answer to division. Back when we first learned how to divide and we were using long division, we had our dividend under the sign, the division sign, and then we had the divisor out front. So we are trying to divide 1,345 by the number 5. And we walked through this. We had a process where we asked ourselves if that divisor 5 could go into our first term of 1. And if the case is no, then we move on and we include 2 digits instead of the 1. And so we say, how many times does 5 go into 13? And we would decide that 5 can go into 13 twice. Now, remember, after you decided what number to write above the divisor, then we took this number 2 times this divisor 5. So remember that this step is involved, that we take the number up top times that value to the side. So 2 times 5 we said is 10, and we write that under the first part of the number, the dividend. Okay, so that's going to be a big part in just a moment. So let's keep going here. Once you found that 10, remember that the operation after that was a subtract. And I know you're asking, why are we doing this now? We've been working with adding, subtracting all these x terms. We're going to get there in just a moment. But if you remember that we multiplied to get that 10 down there, then we subtract it, we get a new number 3. And then we get to continue our process. So the next thing that we would do is we'd bring down the 4 and we'd ask ourselves, can 5 go into 34? And it can. It turns out it can go into 34 6 times, because 6 times 5 is 30. And then once we get that value, we subtract. 34 minus 30 is 4, and then we bring down the next term. So we bring down 5, and we repeat the process one more time. 5 goes into 45 9 times, and so we'd get 5 times 9 is 45. Subtract that, and we're all done. We have nothing else to bring down. We have a remainder of 0. So 1,345 divided by 5 is 269. Okay, so let's try that again over here with 11. Just one more opportunity here. Sometimes we have to scoot over more than just 2 places. So 11 does not go into 1. 11 does not go into 10. But if we go far enough, we do see that 11 will go into 102 9 times. Now, we write that 9 over the 2 of 102 because we had to go over all 3 of these spots to get that 9. So then we can keep going. 9 times 11 is 99. So we'll work from that 2 back to the left, subtract, and repeat those steps. So 102 minus 99 is 3, and we continue. So next we drop the 8, same thing. 11 goes into 38 3 times. And so 3 times 11 is 33. We subtract that again. 38 minus 33 is 5. Drop down our next value, 7. And 11 goes into 57 5 times. And so we get 55. We subtract that, and we get a value of 2. And this time we do get a remainder at the end. So the remainder is 2, but we were dividing by 11. So what we can say for this is when we got finished, we still had a remainder at the end. And when we first learned this, we might have put remainder 2 after our answer. What we're going to do instead is write that in terms of, here is the quotient I got, 935, but since I had a remainder of 2, that was 2 out of what I was dividing by. It was 2 out of 11. And you're going to see that show up in our polynomial division. So that was just a quick little warm up here, reminding you what division looks like before I showed you 2 quick examples of how the same process works with polynomials. So with polynomials, those are these expressions that have x squared, maybe x cubed, but there's variables and exponents. There's multiple terms with plus signs and minus signs in between. And we can do the exact same things here. And these problems below are already worked out, but I'm just going to show you how they work. We're not actually going to do these steps for now, but it uses the exact same steps we just set up top, where we figure out what to write above the divide sign, and then we multiply it over. So in this first case here, the very first thing that was written was a 2x. And the reason was because when I take this 2x times this expression out in the front, the 2x times the x here gave us 2x squared, which is really good because it matches what was written right above it. And we want that to happen. We want things to go away as we work across. But we would also have to take the 2x times the 2, and 2x times 2 is 4x. So that's part of why we practice multiplying already, because we need multiplication to do these kind of steps. And then you get this new expression, and guess what? The next step, just like it was earlier, is to subtract that away, which is another thing that we practice. And then when you subtract, you get a new term, and then you bring that down. You bring down the next piece. So this 6 came from right there. We drop that down. We repeat the steps, and that's what happened. We found this 3. We multiplied it to x and the 2 to get 3x plus 6. And when you subtract, there's no remainder in the end. And then the same thing happened on the right. Notice there was a piece here. There was a 0 thrown in right here. That's something we're going to have to do today, because we want our exponents to start with the biggest exponent and then work their way down. And 3 would be our largest exponent here. 2 is the next largest. An exponent of 1 would be next. And then there's no exponent over here. It'd be an exponent of 0, but there's no y on this last term. So that's what we're going to do on the back is we're actually going to divide these, but we're going to use a different method, one that's actually a lot easier than what you're seeing right here. This one's useful because it works for any scenario. The one that we're going to practice, though, it's a very quick process, and it's going to apply to the scenarios that we are going to work with. But I wanted you to see these because I'm going to show you these exact same problems on the back, but we're going to find these answers in a different way. So we're going to take this problem right here that had a quotient of 2x plus 3 and a remainder of 0. I'm going to show you how we can get that answer another way. And the same thing over here, where there was a y squared plus 3y plus 3 and a remainder of 29. I'm going to show you where those can come from on the back. So rather than doing the long division, which is really fun, I'm going to show you this other type that's called synthetic division. And synthetic literally means created, is made up. It's not going to look like dividing at all, but it's going to get the same answers. Okay, so I have this little chart off to the side that's showing both types of division for the exact same problem. For long division, there's all those steps that we were just talking about, where we find something, we write it down, we multiply it over, write it below, subtract it, and then continue the process. And when we were all done with that, there was a remainder of 0 and a quotient of 2x squared plus x minus 5. And if you look closely, right down here, underneath this box is that same quotient, because we have a 2 underneath it. That was for the x squared. There's a 1 after that. That's for the plus 1x. And then there's a minus 5 after that. Those are the same 3 numbers that we see in this long division example. And there's a remainder of 0 at the end. So I'm going to show you this one today. It's actually really, really easy if you can follow the steps. It doesn't take as much time as that long division. It just looks very funny until you get used to it. But I'm going to show you how we can get those exact same answers that we did on the front. Remember, if I ever go too fast, you can pause this video, you can rewind and rewatch. But let me show you how to set these up. With synthetic division, we're always going to have a polynomial we start with, and we want to divide it by something, okay? So when we set this up, here's what we do. We take what's written inside the parentheses here. This is the dividend. This is what we want to divide. So we have this polynomial. It's 2x squared plus 7x to the first plus 6. And what we're going to do is only write the coefficients, only writing these numbers before the variables. And so step 1, let's write those down. We have a 2, we have a positive 7, and a positive 6. I'm going to write all 3 of those down. Now what we're going to do now is use the value that is needed to help us divide. So we're going to draw a little box over here, a partial box. Let's call it the magic box. And in this magic box, we're going to use a number that we get from this factor over here. And in this factor, we have an x plus 2. So if you can take this and use the opposite value. So in other words, if you take x plus 2 and set it equal to 0, remember doing that before? If you solve for x, you're going to get the opposite. So instead of a positive 2, the solution is a negative 2. That's the one we want. So whatever you see inside the second set of parentheses, use the opposite number. So negative 2 is going to go in this box. Okay, and again, I know this looks really funny, very strange, but follow along. It's going to be a very simple process. Okay, so you leave a little space here. We're going to draw a line down. We have the numbers from our polynomial. We have this number in our magic box that we got from the divisor. We're trying to divide by x plus 2, and we're using that opposite number from the plus 2, so using a negative 2 here. I'm going to show you how we can get the answer we saw on the front page. If we drop down, we're always going to drop down, okay? That is the first step every time. We drop down the first number. So drop down this 2. What we do next is we multiply this number down below times the number in our magic box. So we are going to take this number times negative 2. So multiply by negative 2 and see what you get. And if we multiply this by negative 2, I'm going to zoom in a little bit here. Multiply by negative 2. 2 times negative 2 is negative 4. Okay, so instead of dropping down this time, we wrote this negative 4 underneath the 7. And what we now get to do with these is add them together. And 7 plus negative 4 is going to give us a positive 3. Okay, so we got a positive 3 now. I'm going to change that. We have positive 3. And then once you get to there, you just repeat your steps until you're finished. So just like before, when we had this number underneath, the next thing we did was multiply it by the number in our magic box. So multiply this by negative 2 and write that over here. So times negative 2. 3 times negative 2 is negative 6. And just like before, that gives us an answer, a remainder of 0. And we're out of numbers to use. So that means we are now finished with this problem. There's nothing left for us to do. So we got a 2, a 3, and a 0 under this line. And now we need to know what those mean, okay? So if we take a look back up here on the front page, you see how there was a 2 in our answer, and then a 3, and then a 0 at the end. Those are the 3 numbers that you just found using synthetic division instead of long division. So if we go back here, here's what just happened. You started with the original polynomial that was 2x squared, and then a plus 7x, and then the constant term c, or the constant term 6 at the end, the number without a letter. What we do when we divide, dividing creates smaller values. So when we divide, the exponent decreases. So in this first spot up here, we had x squared. But since we divided this, it's dropping from x squared down to x to the first. And again, we had an x, now we start working our way down. That's x to the first. Well, the next thing after x to the first is just the constant term, no more x. And then there's a 0 at the end. That's your remainder. And for our solution here, what we got after dividing is we're just going to write what we see under this line. We originally had x squared, now it's 1 less. So our solution is going to have 2x. That's a positive 3 after that, so we'll put a plus 3. And then we have a remainder of 0. And on your assignment today, you're going to show that by putting 0 over what you were dividing by. And while we have this negative 2 inside the box, what we were dividing by was an x plus 2. And that's it. Okay? So I know that's kind of weird. We're going to do this a couple more times so you can get a feel for it. It's actually a very, very simple process. Let's try this again on number 2. So looking at this one, remind you of what this looked like on the front page here. Remember, we had this missing spot that we filled in with a 0. We've done that before, but here's also the answer that we're looking for. We're expecting to get an answer of y squared plus 3y plus 3 with a remainder of 29. Let's say if we can make that same thing happen with synthetic division back here. So I'm going to set up my magic box again. Okay, so the magic box is here. Inside that magic box, remember, it's always going to be the opposite of what you see inside these parentheses. So inside the parentheses right now, we see a y minus 3, so a negative 3. In the box over here, it's going to be a positive 3, okay? It's going to be a positive 3. If you wanted to actually calculate that, what you could do is be very formal and write this as y minus 3 equals 0 and solve for y by adding, and you'll see that y is equal to 3. But in that box is going to be the opposite of what you had. Okay, now for this next part, remember, we start with our original polynomial that has y to the third. And so we write that in. So it starts with y to the third. But remember, in front of that y to the third is a coefficient of 1. And what we use for synthetic division is not the letters, but rather just the coefficients. So the first thing we write down is a 1. Now remember, that 1 was for y to the third. And what comes after y to the third should be y to the second. But if you go up to this polynomial in blue, there is no y to the second. And whenever there's a missing term, we always put the number 0. 0 has been for missing. We did that back when we solved systems with 3 equations in our matrices. So here we put a 0 for the y squared. Now we move on. We need y to the first. And in front of y to the first is a negative 6, a minus 6. So we write that down. And then we go to our constant term at the end with no variable. That would be a 20, positive 20. Okay, so we have everything ready to go. What we're going to do now is we're going to draw the equal line down here, leave a gap, remember, leave a gap, and we're going to repeat those same steps. So let's try this out. Step 1, drop down. We always drop down the starting coefficient. So that would be a 1 again. And then just like before, we multiply this one by the number in the magic box. So we're going to multiply here. So we're going to multiply by a positive 3, and 1 times 3 is 3. You get that far, the next step would be to add those. Two numbers that are stacked now, 0 plus 3 is a 3, okay? And then we continue. So next, we multiply again. So we take the number underneath the line times the number in the magic box, that positive 3. So we multiply this by 3. 3 times 3 is 9. We then add those. Negative 6 plus 9 is positive 3 again. And continue one more time. We have one more spot to go to. So we take 3 times a 3, and that gives us 9. And then we add those, and we get a final value of 29. And if you recall, just like before, that number at the end is our remainder of 29 that we just said on the front page. So now that you've divided, you have everything you need. What you need to remember from this point is that the exponent has decreased from where we were. So we started with y to the third. After you divide, your answer should have an exponent 1 less. So y to the second instead. And then it works its way down. Then it's y to the first. Then there's no more y. We call that the constant term. And then there's your remainder. So the remainder of 29. To write that as a quotient polynomial, we can write that out. So we have, at the very beginning, that's 1y squared would be our quotient. So we have y squared. Then we have a positive 3 with our y, so plus 3y. Then we have a positive 3 for the constant, so we put plus 3. And then we add on the remainder. So for the remainder, we're going to put 29 divided by, remember what we were dividing by, not the number in the magic box, but up here, y minus 3 is what we were dividing by. That'll go last. And again, I know it looks funny, but that is the same result we got on the front page. Y to the second plus 3y plus 3 with a remainder of 29. Okay, I'm going to go through one more of these and then we should be set. So let's try this out again. In our polynomial here, we've got x to the third minus 8x squared plus 4x minus 9. Let's write all these out here. So we have our magic box. We'll set that up. Okay. After that magic box, maybe we start with that this time. After the magic box, we've got our polynomial x to the third. So again, we're not going to use that. We're going to use the number in front of it, which is a 1. So underneath in the x to the third spot, we put a 1. And then we should move down to x to the second. And in our polynomial, that's a -8. Keep going to the 4x. So the x term is a +4. And then your constant term is a -9. So -9. In the box, though, in the dividing box, we use the opposite of what we had. So it's going to be a +4. Again, you can find that quickly here by putting x minus 4 equals 0, adding 4. So what this method does is it uses our solution for the dividing. So we have a +4 right here. Okay, but the steps are all the same. So I'm going to keep going. And again, if I go too fast, just pause that video, rewind as needed. Drop down the first term. So we're going to drop. We have +1. And now start your multiplication. So 1 times 4 is 4. We add those. And that gives us a -8 plus 4 is -4. Continue on. So we multiply again. So multiply that by 4. -4 times 4 is -16. Add those. That gives us a -12. 4 plus -16 is -12. And then one more time, multiply -12 by that 4. And -12 times 4 is -48. One last adding, -9 plus -48 is -57. And you're out of values, so now we're finished. And just like before, after you divide, the exponent should decrease. So we started with x to the third. Your divisor will be 1. Your quotient will be 1 less. So instead of x to the third, our answer is going to start with x to the second. And then we just work our way down. So then it would go to x to the first, then a constant term, and then a remainder. I'll write it all the way out this time. That's your remainder right here. And your only job after that is to write it as a polynomial. So your final answer as a polynomial will be 1x squared. The 1's not needed. It's understood. And then we have a -4x. And then for our constant, that would just be a -12. And then we add on that remainder. It's a -57 over, we were dividing by x minus 4. And that's it. So that's what we're actually going to practice. You are not expected to use polynomial long division for now. If you can use synthetic division, we're going to be set to end out our semester this year. So give it a good try. Show your work along the way. You might make a few mistakes with your multiple